Okay, so it turns out we're going to have to do more than just find the values x equals c, where the derivative is equal to 0, in our search for the extrema of the graph, maxes and mins. It looks like we're going to have to do something involving more than just those c values. There are also other types of values that are important here. And together, these values are called critical numbers. And those critical numbers are what we're going to be looking for here. We're given a function, f of x equals x squared plus 3 over x minus 1, and we're asked to find the critical numbers. Those are the x values. When you say critical number of f, you want these x values that we're about to search for. When you say critical values, you're taking the critical numbers x, sticking them into the equation, and getting their y partner. Those are the critical values. But this is about finding the x values, the critical numbers. And you can see we've outlined the procedure for finding critical numbers of a function f. Step 1, find f prime of x. We'll be using the quotient rule here. Step 2, find the x values where f prime of x is equal to 0. So yes, that is important, but now there's more. Step 3, find the x values where f prime of x does not exist. Take all of those and draw a conclusion from what we've been learning. Okay, so taking step 1, the derivative of the function f prime of x, we'll have to use the quotient rule because this function is a quotient, x squared plus 3 over x minus 1. So that gives us f prime of x is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Now we'll simplify. We get x squared minus 2x minus 3 over x minus 1 squared. And we factor the top. And it's important to do the factoring. Be sure to do that. You want to factor what you have at the end. Okay, so that's f prime of x. Step 2, let's find the values of x where f prime of x is equal to 0. Just set f prime of x equal to 0 and solve that equation. For a fraction to equal 0, the numerator must equal 0. That's always the case. Think about it. So solving the top equal to 0 gives us x equals 3 and x equals negative 1. Okay. Step 3, now we'll find our x values where f prime of x doesn't exist. Well, that will be the values of x that make the denominator 0. So set the denominator equal to 0 and solve for x. X minus 1 squared equals 0 means x minus 1 equals 0, which means x equals 1. And now we're ready to conclude. Thus, the critical numbers of this function f are the numbers x equals negative 1 and 3. And then I go, hey, wait a minute. Something's missing here. Remember what we did? What about x equals 1? That was a value of x for which the derivative didn't exist. Well, take a look at f of x. Is x equals 1 in the domain of f? No, it's not. It makes the denominator 0 in f. I'm talking about f of x, not f prime of x. F of x. So it cannot be a critical number of f if it's not in the domain. Okay, so think about that. A lot of times you'll be doing step 3 and you'll find the value that makes the derivative undefined, does not exist. And that will be included in your list in step 4 of critical numbers for the function f. But in this situation, that value that we got also made the function not exist. It didn't exist. It wasn't defined. It wasn't in the domain of the function, so it couldn't be listed as a critical number.